Hi, hey everyone. I'm Kaizar Rangwala,
I'm Kieran.
I'm Eric.
and this is Gokul, our instructor, and Soham, who both couldn't make it today.
And
And
we're
we
three
are
We
the
are the
Python
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 joyers.
enjoyers.
enjoyers. So, we're part of the data science group, and we developed an predictor for health insurance costs. And so, starting off, basically, 40% of American adults admit that they have trouble with paying their insurance costs for their healthcare. And unexpected medical and health insurance bills are now a top worry for Americans alongside fuel and transportation budgeting, which really shows the scale of this problem. And it can have very severe consequences when people are limited in paying their medical bills and insurance costs. It can often turn them away from getting needed care and filling their prescriptions, which can, be very detrimental to their health. And so we chose this topic because it's obvious that healthcare is one of the most important things in society, and it's a basic service that shouldn't be obstructed by financial difficulty. And by developing this project, we may take a step forward to having more accessible healthcare. So before we begin, we wanted to understand what influential factors are in medical insurance costs so that we can eventually direct our model to learn from these factors to make its predictions. And we also set specific requirements that we want our model to meet so that we can confirm that it's ready to be utilized in the real world. And we wanted to accurately predict healthcare costs using given features and also have a very friendly, responsive UI that can be used by almost anyone. And it should also be able to continuously adapt and improve through feedback and changing circumstances.
And so our goal is to understand influential factors that affect the cost of insurance patients and use them to create an exploratory data analysis that can help us in our modeling. And so we made some graphs to help us along. So the first graph is a scatter plot graph. So as you can see, the x-axis shows the BMI or body mass index, which is basically a measure of obesity, and the y-axis shows charges or how much people pay for their insurance. And the dots are color coded based on whether someone smokes, which would be in blue, and if they don't smoke, it would be in yellow. So this graph shows that smokers have generally have higher charges than non-smokers, and that BMI also has a greater effect on the charges of smokers than it does on non-smokers.
And pie charts help us show how data is distributed among different demographics within the data set. So if you look at the first pie chart over here, the blue represents non-smokers and the red represents smokers. And we can see that the majority of the data set doesn't smoke. But if we look at this pie chart, it shows us that the total charges of non-smokers in data sets is nearly equal to the total charges of smokers in the data set. And so the explanation for this is that the higher numbers of the non-smokers compensate for the higher average costs that the smokers have, as shown by the scatter plot graph.
And one last graph that we used was the correlation heat maps, and we use them to uh, determine the correlation between two variables, as we can see in the heat maps, where the brighter colors mean a higher correlation and the more darker colors mean a lower correlation. And we decided to include both of these heat maps since we trained our models with one hot encoded data and trained them again on numerical encoded data. In the end, we compared the two and came to the conclusion that the numerical encoded method was better as it yielded better prediction accuracy.
Now, we tested a variety of different models to see which one would handle the data best in terms of its nature. And one of them was the decision tree regressor. And what a decision tree does is it makes multiple conditional decisions to eventually come to a prediction of a data point.
Another model that we used was multilayered perceptron. And multilayered perceptron is a supervised training algorithm that learns a nonlinear function for either classification or regression. It takes multiple features, passes them through a defined amount of hidden layers where they are weighted, and then outputs a single result.
So the last model that we worked on is polynomial regression. So polynomial regression is a method where the dependent variable is fitted as the result of a polynomial equation of the independent variables. So each independent variable is assigned a degree and a linear coefficient, and that's used to predict the dependent variable. And this is the method that we ended up using for our model.
All right, and to optimize our models, we used grid search to find the most accurate parameters for each model. And it does this by running through all combinations of parameters from a given list to find the one that produces the best metrics. Using grid search, we are able to significantly improve the accuracy of our models. And so with decision tree, we were able to go from being right 75% of the time to 81% of the time. And for multilayered perceptron, we were able to go from being 9% of the time to 87% of the time. And we didn't end up using grid search with polynomial regression because the improvements weren't that significant.
And so this is the final product in all of its glory. We can predict a dummy's health insurance costs. Let's say they're 18 years old. They have a BMI, a fairly healthy BMI of 20. They're male and they live in the Northeast, and they have no children and they smoke. So we can submit this information to the model, and voila, our estimated charge of our health insurance is $10,300.
Right. After optimizing and training our models, we assessed for their performance predicting test values of our data set and compared them against each other. In the end, we found out that polynomial regression was the most accurate model and used it in our predictor.
So despite the accuracy and precision of our model, the precisions we make are limited to the data set that we sourced, which was from Kaggle, so the credibility is unknown, and it was also fairly small as it was only a little over 1,000 rows, which affects how accurate the product is. So the predictor would be more practical if the model could use and learn from real-time patient insurance data, and also it would be a lot better if the number of features was increased, as there are many different things in the real world that affect the cost of health insurance, many of which were not covered in our model.
Overall, there's a lot of potential for our predictor to make its way into the world and improve many lives.
Thank you so much.